Okay, formula. So for geometric sequences. So if a geometric sequence A1, A2, A3, dot, dot, up to AN, so forth, has a common ratio R, then A sub n equals A sub 1 times R to the n minus 1. In words, the nth term of a geometric sequence is equal to the first term times the nth minus 1th power of R. So in that case, once again, geometric sequence formula, A sub n equals A sub 1 times R to the n minus 1 power. So A sub n in this case is the nth value. A sub 1 is the initial value, first value. N is the nth term number. And of course, R in this case is the common difference. Agreed? So there's our geometric sequence formula. So in this case, we have some examples. Are the following arithmetic sequences? Notice that the question is correct. It's usually easier to check for arithmetic sequence than a geometric sequence. So let's see if there are arithmetic sequences or not. And are we going to need an arithmetic sequence formula maybe? So our first example, we have multiplying by 2. If we start with 1, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, etc. Agreed? And now, let's see, can this be an arithmetic sequence? Well, looking at the first two terms, the 1 and the 2, is there a small difference or a large difference? 1 and 2, very small difference, right? It's 1. Versus 8 and 16, small difference or large difference? It's kind of growing, right? So the difference between 8 and 16, of course, is 8, bigger than the difference between 1 and 2. And now if we look at an even later term, we realize 128 versus 256, definitely, this is not an arithmetic sequence. So, not an arithmetic sequence, and in that case, what can we call this? Well, how about geometric? Could this be a geometric sequence? Notice it's very easy in many cases to check to see if they're arithmetic. And then if they're not, we then go ahead and check for a geometric sequence if it is. May not be, we'll double check in some cases. Okay, so now arithmetic, that means we're going to need a geometric sequence formula, right? Geometric sequence formula, A sub n equals A sub 1, our first term, times R to the n minus 1th power. And there it is, our geometric sequence formula. Okay, so in that case, do notice my slight error at the top kind of goes away. I'll come back and type it in again. For our first case, looking at the first term, the 1. Okay, we're going to use the next term, which is the 2. But let's realize that our initial value is the 1. So A sub 1 would be a 1 for this particular case. So 2 divided by 1. So now we're going to use the 2 and divide it by the first term. Once again, looking at the 1, but we're going to use the next term as our numerator, 2 divided by 1. And once again, in this case, 2 divided by 1 just gives us 2. Let's repeat this again, but let's try a different value. Looking at the 2 now, we're going to use the 4. 4 divided by 2 gives us 2. Let's go for the next case. Looking at the 4, we're going to use the 8. 8 divided by 2 will give us, 8 divided by 4 will give us 2 again. Agreed? And we can try for several different cases if we choose to, or we can say, there it is, we found it. The common ratio is 2. Agreed? Okay, so now that we found the common ratio, A sub n equals, well, there we go. The first term, which is the 1 times the common ratio of 2, R is 2, and it's raised to the n minus 1th power, and that's our final equation. Agreed? For the next case, example number 2, we have multiplying by a third starting from 81. So starting at 81, a third of 81 is 27, a third of 27, 9, a third of 3, 1, a third of 1, a third of a third, a ninth, a 27th, an 81th, etc. Okay, just for reference though. So going back into our example here, 81 is our first term, so be aware it's our first term. Agreed? And now let's figure out if it has a common ratio, and obviously we can see it's not arithmetic also, right? Because there are some large jumps in between the 81 and the 27, and by comparison with 3 and 1, it's significantly smaller, right? So it must be common ratio, maybe. Let's check. 27 divided by 81 gives us 1/3. Remember, if you're doing it with a calculator, you can use the fraction option. Agreed? So I recommend you try your calculators and take 27 divided by 81, hit enter, you get a decimal, go to the math button on the left side, right below the alpha button. Under fraction, hit enter for fraction, and converts it to fraction, 1/3. There you go. Okay, so continuing on. Let's continue checking to see if it's a common ratio or not, just to double check. So 27, look at 27, we're going to use the 9. 9 over 27 gives us 1/3, it works. Going for the next one. Looking at the 9, we're going to use the 3 also. 3 divided by 9 is also 1/3. Simplifies to 1/3, right? So therefore, our common ratio in this case, 1/3. So our formula, looking at the formula, our first term, remember, was 81. And our common ratio turned out to be 1/3. So we have a sub n equals 81 times 1/3 to the power of n minus 1. Going for the third example. 14, 56, and 224, right? Notice I did not list the term number. That's the A1, A2, A3, right? Kind of makes it hard to type in, other than making it smaller as a subscript. Okay, but for reference, let's realize that our initial value is 14. And once again, let's go ahead and find if it has a common ratio or not. So we can see a small jump between 14 and 56 by comparison to 56 and 224. So definitely not arithmetic. So let's check for geometric and divide. 56 divided by 14 gives us 4. And once again, going for the next one, looking at the 56, we use 224 divided by 56 gives us 4. So it looks like there is a common ratio of 4. So there it is. We found our common ratio. So therefore, our formula becomes a sub n, okay, with our a initial value of 14 times our common ratio of 4 raised to the power of n minus 1. And there it is. There's our formula. Okay. For example, number 4. Let me start over here on the left side to make it easier. Otherwise, it may not fit all the ways. So for number 4, we have 189, 63, and 21 as our first term, second term, and third term. Hence the A1, A2, A3 on there. Okay, so let's find out if they have a ratio, but let's first notice their initial value, 189. So for our common ratio, 63 divided by 189 will give us 1/3. And continuing on for the next one, checking the 63 using the 21 divided by 63 will now give us 1/3. So therefore, our common ratio is, in this case, from what we noticed, 1/3. So finally, our formula becomes a sub n equals our initial value, 189, and common ratio of 1/3. So equation, a sub n equals 189 times 1/3 to the power of n minus 1. Hooray! It looks like we completed our formulas in this case. Now the question is, for number 5, for example 3 and 4, find a sub 5. I may not have enough space. So how about if we try in the next view? So going for the next view, and I will just briefly restate our equation, so some connections before we do that. If f is an exponential function of the form f of x equals ab to the x, then f1, f2, f3, up to however many cases you want to check, is a geometric sequence with common ratio equal to the base b of x. So hence the reason why I have f of x equals ab to the x. So on problem number 5, for example, number 3 and 4, find a sub 5. And in this case, let me write down the formulas here. So for the first case scenario, that way we can compare it. Definitely, we can see that built up. The function f of x equals ab to the x. The a is the 14, and the v would technically be the 4, right? Okay, and then the x would be n minus 1, but you'd have to simplify it quite often. So it definitely looks like it is a connection with the exponential equations. So in this case, try an a sub 5, the fifth term. So let's omit for now the connection, but let's check for the fifth term. What is the fifth term value? So that means we're still using the 14, we're still using the 4, but now in this case we know the n value, in other words the term number is the fifth term. So number 5. So in other words, 5 minus 1, substituting the 5 in, again in here. In this case, our exponent is 4. So therefore, we can simplify this. Keep in mind, order of operations still applies. So we have 14 times 4 to the power of 4. We cannot multiply 14 times 4 yet. We got to do the exponent first. So doing the exponent first, 4 to the power of 4, this might come in handy where you use your calculator maybe and clear anything that you might have. So there we go, calculator. And we're going to put the 4, caret key, right below your clear button, push the caret key, and put a 4, and then hit enter. That gives us 256, agreed? So there we go, 256 times 14, right? So let's multiply times 14. So notice I just had to hit the times and then put 14, and it gives us the previous multiplication of 256 times 14. There we go. So we get that a sub 5 equals 3584. So the fifth term, the value of the fifth term for problem number 3 is 3,584. All right, so for number 4 in our previous problem sets, let's fill in our equation from the previous case. We have 189 times 1/3 to the power of n minus 1 is our nth term value. Okay, so a sub 5 is the case that we're trying to find out what is it. So we're replacing the n with the 1 because it's the term number. Once again, term number. And let's realize we're doing the same steps as before, right? 5 minus 1 gives us 4. So 1/3 to the 4th, right? Be careful on how you enter this in your calculators. So in this case, plugging it into your calculator, I realize it might come in handy, right? So put a parentheses, then write 1 divided by 3, close your parentheses, and now use the caret key below the clear button. Caret key, and then go ahead and put your 4. If you have a T84, the only difference is it erases the 4 into a little box up higher. Now hit enter, and there it gives you the rough approximation. So there's a rough approximation, and we're going to multiply it times 189. So times 189, hit enter, and it gives you the rough approximation value of 2.33. So a sub 5 is 2.33, or you can have the calculator do a little better of a job for you by hitting the math button right below the alpha button, so math button. Hit enter on the fraction option, and it'll convert it for a fraction for you. So the fraction equivalent is 7/3. So we can say the decimal approximation, 2.33, or the exact value, 7/3. Either would be fine in this case scenario, okay? So there it is. We found for our particular case the values of the fifth term for both the third and fourth problem. Agreed? So just for reference, before I do forget, this should have said finally overall geometric. Agreed? So this is our geometric sequence formula.